Hey guys, welcome back to another video of the non-existent series, The Science Show. Today we'll be talking about KMT, aka the kinetic molecular theory.
First, what is the KMT? The KMT is the scientific theory that revolves around matter. More specifically, its states. First, solids. Solids are made up of tightly compacted molecules with little amounts of energy and movement. Solids are typically malleable under certain circumstances, but otherwise maintain their own shape. Solids are also typically more dense than their liquid form, with a rare exception of water and ice.
Second, liquids. Liquids consist of molecules that are more slightly spaced out than solids, with more energy and movement. Liquids fill the container that they are placed inside. Third, gases. Gases are incredibly spaced out atoms that leap all over the place with energy. They have high energy levels and movement, and fill virtually everywhere that they exist. However, they can dissipate if other gases conflict.
Fourth, and less acknowledged, is plasma. Plasma consists of atoms that have lost their electrons and is in a gaseous state after being heated at extremely high temperatures. Fifth is a practically unknown state of matter, the Bose-Einstein condensate. It is really mysterious and incredibly complicated, so we will commence a deeper dive next video. Essentially, the Bose-Einstein condensate is a selection of particles that get so cold that they act as one, still and unmoving.
And when these particles are heated, energy is added, which increases their movement, making them bounce off of each other, taking more space when making material expand. This is called thermal expansion. And when cooled, energy is lost, which slows the movement, taking less space, making the material contract. This is called thermal contraction. Now, we will present a demonstration.
Hello and welcome to Ethan's Science Lab. Today we'll be experimenting with thermal expansion and contraction. Here I have a balloon that I filled with gas, a tape measure, and some tape that I taped on the balloon, okay, around the circumference. Okay, so first we measure the circumference, okay? Measure the circumference. Measure the circumference. So right now, the balloon should be. This balloon is around 67 centimeters. So now, I'm going to heat up the balloon. Okay, now that the balloon is pretty warm, now let's check the circumference. So, from here to the other side, once again. Okay, go past this tape. We'll go to the other side. Now the balloon has increased by 1 centimeter. Now around 68. It's increased by around 1 centimeter. Okay, and then now I'm going to run the balloon under a cold tap. And we will now observe both thermal contraction. Okay, now I have ran the balloon under a cold tap. Measure it once again. So I've got it down. Okay, the balloon is cold. Now it's also dry. So now we will measure once again in the same spot. So from one piece of tape to the other piece of tape. Cool. Right there. The balloon is now 67. It has decreased. The balloon is now back to 67. So it went from right here to now it is back at 67, or right there, okay? So, now you see how the circumference increased and decreased. But why?
Well, as we have said, thermal expansion and contraction kicked in. If the balloon and its gaseous innards are heated, they are injected with more energy. This makes them move around more, taking more space and growing the balloon size very slightly. The same is with thermal contraction. Once it was cooled down, the balloon and its innards slowed down, taking less energy as the energy is stolen. This makes the balloon shrink in size. Some other examples you might have seen are when two glass cups are stuck together, but when you cool, the two contract and you are able to pull them apart. The metal gaps in large bridges allow the bridge to expand and account for thermal expansion and contraction. These are two examples.
States of matter are also able to turn into each other. Solids can melt into liquids in fusion and vice versa in solidification. Liquids can vaporize into gases and vice versa in condensation. Next, gas and solids are actually able to turn into one another. Sublimation turns the solid into a gas without going through the liquid state, and deposition turns the gas into a solid.
Plasma and the Bose-Einstein condensate are also able to be formed by any other form of matter. When any form of matter is heated at extreme temperatures, the electrons will detach and turn to plasma. The Bose-Einstein condensate is the same. Chill the matter enough and it will turn into practically a singular particle.
In conclusion, these are the basics of kinetic molecular theory. We hope you learned something. Please remember to like and smash that subscribe button. See you in the next one.